This is a review of the new Rigol DS2072 DSO. I think it's been on the market now for maybe 4 months, 5 months. Those of you who've seen my other reviews know that I briefly owned one of the Rigol DS1052Es, one of the O1 SDS7102s, and one of the Handtech DSO 5062Bs. All of which I returned because I was frustrated or unhappy with certain aspects of each of them, and I didn't think it was worth letting that money go for a device which frustrated me in some way. So when I heard about the Rigol DS2000 series coming out, I was curious about whether if I spent 50 or 60% more than one of those lower end models that I mentioned before, whether I could finally get a scope that would satisfy me, would make me feel like it would be something I'd want to own and use for several years to come. So I wanted to examine some of the special features and specifications of the Rigol DS2000 series that make it very interesting, the selling point, so to speak. And the first thing I wanted to look at was the waveform capture rate. Now, the specifications for the DS2000 series say that the Rigol can capture up to 50,000 waveforms per second, which is an exceptionally good rate for its price class. So I wanted to test this. Fortunately, the Rigol has a trigger out, which makes it very easy to test, since the trigger output is the average frequency of the waveform capture rate. So that's the first thing we're going to look at. We're going to send a 1 megahertz signal in, and we're going to read the output of the trigger out on a frequency counter. According to the material I've seen on waveform update rates, it appears that every model of DSO has a kind of sweet spot, the sort of optimum or best case setting for the time base where it can capture the most waveforms per second. So I've been playing around with the Rigol DS2072, and it seems to me that its sweet spot setting for the time base is 20 nanoseconds. So I have this set to 20 nanoseconds time base, and I've got the memory depth set to 14 kilopoints, the smallest setting possible, because that's the only way we're going to achieve that 50,000 or close to 50,000 waveforms per second. And we're going to now turn on the fluke, set it to count. Let's get the light on. And you can see we're at about 45,500 waveforms per second. It's interesting to note when I change the memory depth here, let's say I go to 140 kilopoints, the rate now drops to about 14,000 waveforms per second, and then as I go down, for every 10-fold increase of memory, it actually decreases by exactly a 10-fold on the waveforms per second. So 1.4 megapoints becomes 1,400 waveforms per second, and 14 megapoints becomes 142 waveforms per second. So it follows exactly the memory increments up until that jump from 140K to 14K. And there we are back to what is more or less the specified waveforms per second that Rigol claims, which is around the 50,000. For those people who aren't quite sure about how the waveform update rate affects the scope's blind time and the possibility of catching glitches, I worked up a little comparison here, an example, let's say, between this scope and the O1 SDS7102, well, because I previously owned that scope, and I know its precise waveform capture rate, and also the Rigol's very fast and the O1's very slow, so the comparison is very stark. But let's say you have a glitch, a signal fault that's happening once per second, and you want to know what the average time might be to catch that glitch on the scope with a probability of 99.9%. You always have to include the probability. Well, the math says that given at the 20 nanosecond time base setting, and given the, say, 50,000 waveform refresh rate of the Rigol versus 35 waveforms per second refresh rate of the O1, that the average test time for the Rigol would be about 8.2 minutes to catch that glitch, and the average test time for the O1 would be about 5.4 days. to catch that glitch. The next feature I wanted to check on the new Rigol was the Skippy command set. This is the feature that is in most serious oscilloscopes, I mean DSOs, and is lacking in the cheaper Chinese brands like Hantech and Owen and so forth. And it's a feature that I sorely missed once I got rid of the Rigol 1052 and tried using the Owen and the Hantech. So what I've got, basically the feature allows you to interface with National Instruments Visa driver, which allows you to easily write software to control the scope or to interface it to other control software very easily, such as MATLAB or LabVIEW. So to test it, I fired up a piece of software that I'd written for the 1052E, which takes measurements from the scope and displays them in a box on a PC screen, very large, so easy to read. And so I've got the scope hooked up via excuse me, USB cable, and I've installed the necessary Visa drivers and so forth. So here's the software here on the PC screen, and I'm going to say I want the peak-to-peak measurement of channel 1. You can see I have a sine wave over on channel 1. I'm going to start it, and sure enough, it is getting the peak-to-peak voltage from the scope. You can see down here at the bottom of the scope, it's popped up here as well. So if my software asking for it has also turned it on the scope itself. And if I add a couple more measurements, let's say maximum, minimum amplitude, you can see those pop up on the scope as well. So I looked through the programming manual for the DS2000 series, and the Skippy command set looks very similar to the 1000 series. It looks like they've changed the nomenclature of some of the variables and stuff, but for the most part it looks quite similar. So a lot of software that was written for the 1000 series should run either directly or with very little changes. And it's very easy to use. You can see I whipped up just a tiny little program here in 10 minutes that uses the record open function. I can start and stop it here by clicking these buttons. You can see over here now it's recording frames in those segments, and I'll go into this a little bit more later, but I just wanted to show me starting and stopping it via a small piece of software I wrote. One thing about the new command set for the DS2000 series is that it appears they've added a whole lot more power to the command set. So there's a lot more you can do, it appears, from just a cursory glance through the manual than you could do with the 1000, which I really appreciate. So I'm happy about that. Another feature I wanted to look at were the triggers and the decoding functions of the scope. The DS2000 comes with quite a great assortment of triggers built in, plus you can add on more as part of an option package. The add-ons are, as well as the decodes, which are also an option package, are included when you buy the scope as a trial option for, I think, about 35 hours worth of playing with. But Rigol did one clever thing, at least I think it's clever, in that they gave you for free, as part of the built-in triggers of the machine, they gave you RS-232 SPI and I2C triggers, even though, but the option to decode those is a separate purchase. So they gave you the triggers for those things, but not the decoding, which is kind of clever. So anyway, we're going to test the I2C trigger. I've got a little artwork of mine called the jewelry box hooked up to the scope, and it uses I2C to communicate with a clock chip and an EEPROM. So let's see how that works on the scope. I've got a little piece of cardboard covering the LDR. Remove that.
Always together. Forever. Never.
You can see the scope is re-triggering at each
After 28 times open.
start bit. Now we're going to look at the I2C triggering with the decode turned on as well. So let's trigger that thing.
Always.
You can see it's saying whether it's a write or a read, where there's data.
Forever.
That little red mark is showing that there's no acknowledge there where there should be.
Never. Even after 29 times open.
The decoding is quite nice, and you can also call up from the decode menu an event table which shows you the events in a kind of spreadsheet form, and that works real time, where if I
29th time at stage
trigger more events, you'll see they're changing here.
Penalties.
This also mentions here that this was acknowledged, this one was acknowledged, but this one is the one that had no acknowledgement. You can export this as a CSV file as well. That's very handy. I like this feature. The next thing I wanted to look at was the measurement system on the Rigol DS2000 series. They've done some pretty cool things with it. First of all, they've got a dedicated bank of menu keys, this side, the left side of the screen, specifically for measurement. So if you press the menu button on top, the side menu pops out. In this case, the last thing I chose was horizontal, so it's still set to horizontal. If I press it again, it'll alternate to vertical. One more time, it goes back in. I can bring it back out, it stays at vertical, back to horizontal, back in again, and so forth. And when the menu's out, of course, you can use the page up and page down keys to go to other selections which aren't on the initial page of menus. So obviously, once you choose one of these, they appear down here at the bottom of the screen. I can go to the measure menu over here, and I can clear all of those instantly. And now we can select some new ones. So we could take fall time, width, period, go to vertical, V-min. If I wanted to, I could press the channel 1 button, and then I would be selecting measurements for channel 1. See, channel 1 measurement now. This is kind of standard, the way they're displaying here for most scopes. But the measure system is much more complicated than that here. So if we go back to the measure menu here, not only do we have the standard display, we have what they call statistic display. So if I put that on, all of a sudden it pops up higher and gives you a little icon graphic of the measurement that's being made. And it gives you added information. And you can set that added information here with the status select. You can select it either to be the difference, which is standard deviation and count values, or it can be what's called extremum here, which is minimum and maximum values. Also, similar to the Rigol DS2000 series, there's the display all setting, and I can choose what the source of that all measure is here. So I can say both channel 1 and channel 2, or just channel 2, or I can have math on there. Let's say channel 1 and channel 2, and display all. We'll put all of the possible measurements for both channels at the top of the screen. Another thing in the measurement section that's nice is they have the standard cursor settings for taking measurements, but from the measure menu you can actually choose the measurement range, and that lets you say screen region, or you can say cursors, and you can then specify the cursor area to be used for the measurements. All of the measurements are then affected by these cursor settings. So there I'm moving cursor A, cursor B, and then of course the two of them together. Okay, the last thing about the measurements that is especially cool is that the Rigol has what's called a measurement history, and you can turn that on and you can show the last 10 measurements taken from up to 5 specific different measurement items in either graph or table form. So if I turn that on, you'll see here it is in table form, last 10 measurements taken, and if I put it on in graph form, you see a graph. That becomes especially interesting if, for example, let's say I start a sweep. Here I've started a sweep a logarithmic sweep heading into the scope, and you can see the graphing of the statistics of the fall time, width, period, minimum. This is fantastic, really fantastic. Here's another really nice little feature I wanted to point out. In this example, I've set the trigger to be a pulse width, and you can see down here that I can set, of course, the width of the pulse I want to trigger to. On the DS2000 series, when you have a variable to change that has quite a broad range, you'll notice the standard icon for the multifunction knob, but you'll see a second icon as well, which is for the navigation knob. That means you can use the multifunction knob for changing the variable in small increments, as is usual on DSOs, but you can also use the navigation knob for changing the variable very quickly through its entire range. So that saves you the frustration of spinning this thing constantly to get from one extreme to the next. Another feature I wanted to point out that's quite nice on the DS2000 series is the waveform record utility. Now the 1000 series has the ability to record frames by specifying start and stop frames and so forth, and so does other low-end DSOs, but the DS2000 series has expanded very nicely on these options. One of the ways it's expanded is it now has a mode, it has a standard record mode, but it now has a mode called open, which means that when it's put into open mode, it segments the memory, and it's constantly writing to, in this case, because my memory is set to 14 kilopoints, it's segmented it into 4063 divisions, and it's constantly writing over those segments with new information it captures as long as it's running, whether it be in auto mode or whether it being triggered in normal mode. It's overwriting those previous segments, and at any point you stop the oscilloscope, you'll see that has turned green, and now those last 4063 frames that were recorded can be examined and analyzed. So right now I'm recording an amplitude modulated waveform. You can see that I'm using the open mode, and so it's just running continuously, overwriting segments as it gets to the end. And now I'm going to stop it by pressing run stop, and I'm going to enter the analyze mode. And when you're analyzing, you have your choice of two different methods. One is the standard pass fail, which is what it's set to right now. You create a mask, and if as it compares frame by frame, if the waveform falls outside of that mask, you'll have an error frame and what they call a frame difference of 100%. So in pass fail, there's only two responses to a comparison: 0%, meaning the frame passes, or 100%, meaning the frame fails. But what's more interesting is this other method they have, which is the trace analysis. When you use the trace analysis, you first create a template. I'm going to do that by pressing this button here, which will take the frame that I happen to be on and create the template for it, and you'll see it appear over here where it displays the template. Now the template is used to compute the difference between the trace in that and the trace in every subsequent frame, and you can set the threshold for what it considers an error frame. So anything above 10% is considered an error frame, anything below is considered okay. But not only will you get the number of total error frames there are, the scope will create a histogram down here, a timeline with a histogram on it showing the difference of every particular frame to the template using this color scheme here for the histogram. So I'm going to start this running now. Now I've jumped forward to the end of the 65,000 frame analysis, and you'll see it's created this fantastic histogram down here at the bottom showing the difference of every single frame, and it's saying that from the template I created, it found above that 10% threshold, it found around 40,000 error frames, and the other ones all fall within the parameters. And you can use buttons over here to jump to the next or previous error frame, And of course, you can also use the navigation knob to jump through frames, and you see the histogram moving as the cursor, my current position, changes. This is just fantastic stuff from Rigol here. Really a great tool. So what are my first impressions of the scope? Well, I have to say, after having used it for 2 days, that I think it's fantastic. I think the build quality is excellent, the weight, the construction, the design, the screen layout, the features, all of it is very top-notch. In fact, it feels like it's a whole different level of quality, a whole different level of professionalism when compared with those other 3 scopes that I've owned. Rigol really seems to have put a lot of thought and work into this series. Real attention to detail, such as the multifunction knob being used for intensity grading when it's not being used for anything else, so you can change the intensity of the waveform. Just everything, all the various functions they've thought through very well. The firmware seems very stable. I was only able to identify 2 bugs, which have both been reported before. That is the X and Y axis being reversed in XY mode, and also there's a bug that when you self-calibrate, you lose the trial options. But I know that Rigol has been giving out extra trial licenses to people who've accidentally lost their trial license by calibrating. So I don't really think those are, that's not such a big issue. Other than that, the firmware extremely stable. I wasn't able to find any other bugs, and I didn't have any problems with the scope hanging or crashing at all. Is it perfect? Well, no, of course not. But everything that bothered me about it are all what I would say are minor annoyances. Nothing major at all, which is the first time that's happened for me with a DSO. Some of the annoyances, I'm still a little sad that the screen space is wasted when it's not being used for menus. It's empty instead of being filled with waveform, but I understand with DSO manufacturers that it's always a trade-off between screen real estate and waveform capture rate. So although it would be kind of nice to have the full screen being used all the time, on the other hand, the layout of the screen and the way they use the space is exceptionally good, I think, and better than what I can see from the Agilent 2000, 3000 series. Another thing, I appreciate the fixed menu keys on the side for measurements, but you'd kind of think with all these menu keys around that there'd be at least a couple that were soft keys that were programmable, but again, a minor thing. Another annoyance is that I wasn't able to locate, this could be something that I just missed in the features, but I couldn't find any way to save frames once you've recorded frames, either to external storage or to the USB stick. It appears, from what I can tell from the programming manual, that you can retrieve the frames via the Skippy commands, but still it would be nice to be able to save them to USB stick. The last little minor annoyance I wanted to mention is that I've never been a real fan of selecting things by having to push a rotary knob. Maybe it's just me, but at least one time out of every 3, when I select something this way and push, the selection jumps one forward or one backwards and selects the wrong thing, and I have to do it again. Given that those are the worst things I could say about the scope at this point in time, you can probably gather from that I really like this scope, and I'm definitely keeping this one. I also want to just point out a little something about the price. I noticed that when Rigol introduced the DS1052E in 2008, the initial price was $595, which, you know, taking inflation into account, in 2012 dollars is about $640, and this scope is priced around the $840 mark. So it's about a 25% increase over the introductory price of the DS1052E, and it's way better than 25%. It's a big jump up in terms of quality and features. So for those of you who are on the fence about purchasing a scope and you're wondering how much to spend, whether you should get one of the OONs or one of the Rigol 1000 series line or one of the Handtechs, and you've seen this scope and you're wondering whether it really is worth maybe 2.5 times more than what you might have to spend for one of those other scopes, let me tell you unequivocally, yes, it's worth way more than 2.5 times those scopes. This is a scope that I will be enjoying for many years to come. One last thing I wanted to mention, if you live in the EU and you're thinking of buying this scope, or any DSO for that matter, you might want to consider Silicon Electronics. That's a small company run by Peter Schmidt. Some of you might know him as Drig on EEV blog, who helped many people with their bricked Rigol 1052Es. He has this scope at the same price as Betronics with free shipping within the EU, but he has much better before and after sales support. So I highly recommend buying from him if you're in the EU. So that's all for now. I hope to do a follow-up perhaps in another couple of weeks after I've been using the scope for a while with any further faults or bugs I find, and maybe a further exploration of some of the features. But that's all for now.